Hello my little pre-calculus chickadees. It is time for 3.6 critical points and extrema. This is a quick one. Please make sure you've got your calculator handy. It's going to make everything much easier. These are the main things you're going to need. Second, trace, 3 for minimum, and 4 for maximum. That's going to make your life a whole lot easier. Okay, critical points are points on a graph at which a line drawn tangent to the curve is horizontal or vertical. I don't know how much you learned about tangent in geometry, but a line tangent to a curve is a line that goes through this point and doesn't touch the curve anywhere else. And for any point, well, I say anywhere else, doesn't cross through that curve anywhere else, if that makes sense. It's not going to touch, it's not going to cut through it, it only touches right there. So if you want to test it, what you can do is, if you do second program, this goes into the draw menu, and you choose, let's see, 5, that'll get you the tangent, and then you can type in the x value that you want to check for. So I'm going to show you that in a minute. But that's how you can double check whether you have a critical point or not, because if it's a critical point, the tangent line will be horizontal or vertical. So, kinds of critical point. Absolute and relative maximum. All of this is a repeat from Algebra 2. Absolute if it's the highest point anywhere on the graph. Relative if it's the highest point in its neighborhood, but there are other higher points later, or earlier, or somewhere else. Same with minimum. And a point of inflection is a place where it sort of changes curvature, but it's not a maximum or a minimum. Okay, locate the extrema for the graph and name and classify the extrema. Okay, let's see what's going on here. Hey, that's an extremum, a single extrema. And where is it? It is at 0, 2. It is a maximum, and so far as I can tell, and I have to work based on what I can see of the graph, it's the highest point anywhere on the graph. It only goes down in both directions, so it is an absolute maximum. See how easy that was? Here, I seem to have a minimum, and so far as I can tell, it's the lowest point anywhere in the graph. So it's going to be an absolute minimum at -1, 0. Here, okay, this is the highest point in its neighborhood, certainly, but there are other higher points later on in the graph. So that makes this a relative maximum, at -2, -3. And this point here, it's the lowest point in its neighborhood, but the graph goes below it at other points, so it's also going to be relative. Relative minimum at 0, -4. Since this graph goes down forever this way and up forever that way, there are no absolutes on this graph. A graph can have many, many relative maxima and minima. It could only have, at most, one absolute maximum, one absolute minimum, because that's what absolute means. Okay, it looks like a relative maximum and a relative minimum and an absolute maximum, right? Highest point in its neighborhood, lowest point in its neighborhood, highest point anywhere. The relative max is at -2, -1. The relative min is at 1, -3. And the absolute max is at 2, 4. It's a good, probably more than half of what we're going to do. Use a graphing calculator to graph it and determine and classify its extrema. So, hello little graphing calculator. X to the third minus, caught me again, minus 8x plus 3. This is where this is where your calculator is going to be really handy, because it's not falling at integers, so you won't be able to tell from the table or even just by looking. I want to see more of this. Let's see. For some reason I had my y min set to -20. I don't think I need to see that far. Let's set y max to 15 so we can see a little higher on the graph. Okay, now I can see, so far as I can tell everything. I'm going to take it on faith that this is all I need to see. Okay, well that looks like a maximum. But it's not the highest point anywhere on the graph, so it's going to be relative. And we've got a relative minimum. To find these things, second, trace, to get into the calc menu. And first we'll find the minimum. First we'll find the maximum. Go left to right. Okay, so second trace 4. Now it's asking for a left bound, so we're going to move this until it's to the left, move it until the right, and it asks for a guess, so just about there. And it tells me that the maximum is at negative 1.632994, and the, for the x and y of 11.7. I'm going to go ahead and round that, so this will be negative 1.6 comma 11.7. And I've never been able to get that from the table. So let's do the minimum. Second trace 3. Somewhere between here and here. And the relative minimum is at 1.6, negative 5.7. Be careful, if you ask for the maximum when you actually mean minimum, it'll try and find the highest point in the area you picked, but it's not going to be what you want. So make sure you're pushing the right button. And that's it. That's all there is for that one. Sometimes they will tell you where the critical points are. So this function has critical points at x equals 0 and x equals 1. Determine what kind of critical points they are. So I am graphing the function. Okay, so they both see, so we want the ones at 0 and 1. They seem to be right there. Let's see them a little closer. Oops. Oh well. Of course it goes off the graph. Well, doesn't really matter. Okay, this point here, it is a critical point, and to verify that I'm going to go into the draw menu, choose tangent, and say x equals 0, and it will draw the line that has the same slope as just that point on the graph. It's a little complicated, but that's the basics of it. And you see that this is a horizontal line. So that is a critical point, but it's not a maximum, because the points to the left of it are higher and the points to the right of it are lower. And this is not a minimum. That is a critical point. So at 0, actually technically at 0, 0, there is a point of inflection. That's what it's called when it changes curvature, but it's not a maximum or minimum. And over here at 1, that's a minimum. In fact, it looks like an absolute minimum, but it's not asking that. It's just maximum, minimum, or point of inflection. So at 1, negative 1, there is a minimum. Okay. 1 hour after X milligrams of a particular drug is given, the body temperature is given by T of X equals X minus X squared over 9. Model has a critical point at X equals 4.5. Determine what kind of critical point it is. So you would graph X minus X squared over 9. I want to go ahead and see my normal window, so I'm doing zoom 6. It goes up, it goes down. Now, we could do the second trace thing to find out where exactly that point is. They tell us it's at 4.5 though, so we're going to trust them. And that is definitely a maximum. So what kind of critical point is this? It is a maximum. Why should a doctor be aware of this? Well, if that's the point or the time when there's the highest rise in body temperature, that's really when you want to look out for dangerous temperatures, right? If it's dangerously high temperature, you can have damage. Okay, I don't know. I'm not a doctor, but it makes sense that they'd want to look out for it. Locate the extrema, name and classify. Okay, I've got a minimum here, and here something's happening. let's do this one first. This is a minimum. It goes below it later, so it's relative. So there's a relative minimum at, okay, count it on your own time, -3, -2. This, what's going on here? Well, this point is the highest in its local neighborhood, right? It's everything to the left of it is below it, everything to the right of it is below it. So this is a relative maximum. Not absolute because it goes higher than it over here, but relative. This isn't actually anything, it's just the other side. So there is a relative maximum at 1/6. This one, right there and right there, but there are no absolutes at all. That's okay. Rel min, -1, -3. Rel max, 3, 3. Ooh, all done. Use a graphing calculator to graph and to determine and classify its extrema. So again, adjust your window so that you can see everything you need to see about the graph. Use the second trace and then 3 and 4 to find where the maxima and minima are. So, number 6, please put this in your calculator. What's going to happen, you're going to find a relative maximum. Go like this. If you ask the calculator what that point is, if you ask the calculator what that point is, it's going to say, let's see, look like -1.7e minus 6, comma, -4.42e minus 23, or at least that's what mine did. This is scientific notation, so this is saying -1.7 times 10 to the -6. So what is that? That's 0.0000017. That's a rounding error. It's just having a mistake rounding. You want to call that 0. That should be 0. It just had a little error because calculators have to round sometimes. And this is an even smaller number that's got 22 zeros before the 4. Sorry, negative, it doesn't matter. So this is an even smaller number, so that's also 0. So the relative maximum is actually 0, 0. Make sure when you see these, you never write them down, because that's always a rounding error. Okay, rel min will be off your graph, so change your window. It's at 2, -16. Number 7 has a point of inflection. You'll see that it changes its curvature at 0, -2, and an absolute minimum at 2.3, -10.5. These 4, they tell you exactly where the critical point is and just ask you what kind it is. So graph it, look right there, don't look anywhere else, you're only looking at there, and tell it what happens. So this one, please check this on your calculator, don't just take my word for it. This one is a maximum, this one is a minimum, this one is a point of inflection. It's not a maximum, it's not a minimum, but it does change curvature. And this one is a minimum, and that is everything.